Hello everyone, I'm going to start the development of the CocoaPod library here for calendar outlook. As you can see, I have the two Xcode projects setting up here, one for the CocoaPod library itself and the other one for the target application using that CocoaPod library. So right now on the left side, this is the view controller of the target application. And then on the right side, it is the HN calendar view, which is the main class of the CocoaPod library I'm building. Say I want to start applying this library to my target application. So for example, in the view controller, I'm going to add this calendar view to my view controller and also the view here. Say I am creating an object of the calendar view. So at this point, it is not fine. So there are several reasons. First, in order to use a library, I need to import that first. And as for the Swift case, every library that we want to use should be imported as a framework. That's why upon setting up the pod file, we already set up the use frameworks so that every library will be compiled into framework before importing to the target application. Thus, I can put import here with the name of the CocoaPod library. In this case, we have set it to HN calendar view. So we have import the library. However, it is still not fun because for every framework class, if we want to use in the target application, we need to set them into public. So by default, without specifying, it is internal, meaning that the class can be accessible within the framework or within the same module. If I set it to public, it can be accessible from another framework or module. If I set it to private, it is only accessible within the same file. So in this case, I'm going to add public. When I set public to the class, it will ask me to set public to some of the methods. For example, all the overriding methods. I can fix it here. And then this one. So right now, this class should be accessible in the target application. At this point, it is still not showing as class find. We can run the application so that it recompile the framework and make sure the target application knows that the existence of the class in the framework. And then now it is compiling successfully and the application can be run. In case the highlighting of Xcode is not updating yet, we can simply choose to a different file, switch over, and then come back. It will have the highlight now. Then I'm going to add this to our current view, and also this class itself is an NSView controller. In order to process the lifecycle methods correctly, we want to first add child view controller to include calendar view to our current view controller hierarchy. And then in order to display the view inside, we want to first set the theme of the view. Say the same as the current view's theme. And then lastly, I want to add the subview to our current view in this view controller. This is similar to other view hierarchy structure. So right now, we are able to add the calendar view to our current view controller. Let's try to run the application. But then, when we run the application, we got the error appearing. Basically, it is saying the view is not defined. In general, we define the view in two ways, one or another. The first one would be to do it programmatically, basically assigning a new object of NSView to the view property of the view controller. Or we can do it using interface builder, meaning we can create a lib file or storyboard where it binds the visual view to this view controller. We will do both ways here one by one just to show you, but I will start with the one programmatically and then later on turn it into the one using a lib file. And eventually we'll be building the library on top of the interface builder way as well. So at this point, in the library, we can override the load view method and set the view's property to our new object of NSView. Just that, and then run the application. In fact, even the modifiers can be put in different order. I want to keep it similar way as the other overriding methods. So this time, as the view is present, and when I run the application, the error goes away. Just to make sure it is working properly, the first thing we could do is to show the view hierarchy. Now, at the top of the view hierarchy, this one is an NSView. It's still not clear because it's as simple as an NSView. Why don't we create a label and then add it as a subview of this view? Say I have a label here, which is NS test field, and then say within the load view method, besides creating the new NSView object as the base view, we also create the label as an NS test field object. Set it with a theme, say at the position of 50-50 and the width height as 50-20. So the content as label, and now we add this label as a subview to the base view. So now if I run the application, I expect there is a base wheel in this calendar view, and also show a label on top of it. So as you can see, it is now showing up. That means we have added the calendar view successfully. As I mentioned, we can create the views programmatically like this, or the second way to create these views using the lib file. In this scenario, before I created the lib file, I would want to switch back to the CocoaPod library project. As I mentioned in the previous section, when we create any new file, we want to switch back so that we can create the file under this project and then run the pod install in the target application again. So now let's first remove the programmatic code in creating those views. And now under this asset folder that I just created, I want to create the user interface using view, which means it would eventually make it as a lib file. Let me navigate it back to our project. And then under the CocoaPod. And I'm going to create the assets folder here. And call this the same name as our current class. As you can see, now it creates as a lib file. And then let me drag the label here, say appearing at the middle of the base wheel. While I created this lib file, I shall relate this to our view controller class. So goes to files owner and then set the class here to be the name of the view controller. And then drag from the files owner to the view here. Okay, maybe like this, okay. And then link it up as the view. So this step does the same thing as the overriding method load view, basically linking up the view of this view controller. And in this case, the view is created in the interface builder. So right now, this part is done. And then we can switch back to our target application and run pod install again in order to load in the lib file. At the moment, we only have the class here, but in a while, we'll have the lib file showing up. And it's currently loading. So now it's done. Take a look on the development pod again. Now we have this resource group with the assets under it and having the calendar view at this point. So now let's try to run the application directly At this point, we will see the similar error, but this time we are sure we have the lib file. So what happened? The problem here is that the lib file is contained within the framework. Basically, the framework has its own bundle, its own module, and for that module, it has its own namespace of the bundle. And for now, if we want to include the lib file, it tries to look for the lib file under our main bundle, which is the target application. Thus, we need to make some changes in order to tell the project to find the lib file within the bundle of the CocoaPod library. To do that, we can create an initializer here. Within, we want to call like the super.init method for the libname bundle initializer. The libname will be the name here. And then for the bundle part, I'm going to use NSBundle for class, and then at this point, set the class of this view controller itself, so that it will first find the bundle containing this class and use that bundle to find the lib file. And then there are some warnings, including the initialization of other, the overriding of other initializers, and also unwrap the initializer here. We shall add public as well, so that it can be accessible in our target application. So say we are setting up this right now, and I can run the application again. So now, as you can see, label is showing up, meaning that the lib file is loaded correctly and added to our current application. The error goes away as well. So that's like the foundation step of adding the target application, the CocoaPod library to our target application. Tomorrow we can start here to make the actual layout of the calendar. So I will see you soon.